Hello and welcome to ACE Level Mathematics. This is Omar Khatan and I'll be your instructor throughout this training series. This reading is based on circular measure and will cover the most tested concepts in the Gcse, Igcse, CAIE, ORC, Edexcel, International Baccalaureate and more. Main topics in this reading are as follows: finding the sector and the arc length of a circle, finding the area of a triangle, finding the area of a segment. We'll see the conversion of degree to radian angle and vice versa. And finally, I will walk you through multiple past paper questions step by step so you know exactly how to handle these questions in the final exam. So, let's get started. In circular measure, first we will discuss about circle. Let's assume this is a circle. In this circle, this middle line, the line which is passing through center, this is called the diameter. This is radius. And here you could see there is an angle theta, and this part is the arc length. Represented by, we have the formula for the arc length. S is equals to R times theta, and this theta should be in radians. If you just consider this part, I just take it out and draw it here. So this is somewhat like a sector with the angle theta, and this is radius, and this is R. And if we want to find out the area of a sector, so we have this formula for area of sector, which is A is equals to 1 upon 2 R square theta. If we want to find out the perimeter of the sector, then we have it, this R. Perimeter is just the boundary. So this is R with this R, so R plus S. So I can write it here, R plus S, which will be 2R plus S. Now in this chapter we will come across with triangles also, so we should know a little bit about triangles as well. So let's draw a triangle here. This is a triangle. We have a triangle which is a right angle triangle because it's making a 90 degree. So we just to revise you some formulas related to triangles, those are, and you can find the area of these triangles so easily. It would be 1 upon 2 into base into height. This is the base of the triangle and this is the height of the triangle. So you can find it directly. If we have a triangle somewhat like this and it's making an angle theta with it, for example, if this is B and this is A, and you have to find the area of this triangle, So we can use half AB sine theta. So this formula is pretty famous, and you'll have to use it here in this chapter. What if you have a circle over here and you have a triangle in this circle? So how would you find the area of this triangle? That would be pretty easier for us if you just consider over here, if you have a triangle somewhat like, what we supposed to do, we just need to take this side, and this angle, and we have this formula then. So for this thing we can do it. First I'll take this side, this R over here, this R over here, and sine of this angle. So this will become half R square sine theta. So you can use this also while solving your sum. Now let's talk about the area of a segment. If we have to find the area of a segment, let's draw a diagram over here. We have this circle, this is the center of the circle. We have this radius and this radius and this part. This is our segment. If we have to find the area of this segment, so what we're gonna do for it, as we know this whole thing here till here is the sector. So what we'll do, we will subtract the area of sector. Area of sector is, we have already learned it, that is half R squared theta. And we need another thing over here, that is this triangle. The area of this triangle would be half R squared sine of theta. So if we have to find this blue part, so what we need to do, we need to subtract the triangle from the sector. So area of segment will be area of sector minus area of triangle. So area of sector is half R squared theta minus area of triangle is half R squared sine of theta. Upon simplification we'll get, taking half R squared common, and we have inside theta minus sine theta. These are the result that you could use directly while trying to find the area of segment. If you want to memorize, you can do it, otherwise you can deduce the way I told you. Keep that in mind, this theta should be in radian mode, should be in radian, and you have to convert, you should know how to convert your calculator into radian mode, otherwise you will get wrong result. You need to be cautious about it. Now I'm going to teach you how to convert degree angle to radian and radian angle to degree. We know that 1 pi is equals to 180 degree and 2 pi is equals to 360 degree. If we are given an angle in the form of degree or in degree, so how I'm going to convert this into radian? I will just multiply this with pi upon 180, and upon simplification I'll get pi upon 3, because 60 divided by 180 will be 1 upon 3, that is pi upon 3. Even if we try to convert this 45 degree into radian angle, so that will be, you just have to multiply with this factor like pi upon 180. That's it, you just need to memorize this. So 45 into pi upon 180 will be pi by 4, because 45 divided by 180 is 1 upon 4, so it's pi upon 4. So you have to just multiply with the pi upon 180 to convert any angle from degree to radian. Now we'll see here how to convert any angle in which is given to you in radian. You have to convert it into degree. So radian to degree, you just have to do the reverse of it. For converting an angle from degree to radian, you multiply with pi upon 180, but when you'll be converting it from radian to degree, you have to multiply it by 180 upon pi. That's it. So let's take any question. For example, if you've been given pi by 6 and you have to convert this angle into degree form, so what you'll do, we'll just multiply here with 180 upon pi. That's your factor. You just have to multiply with the 180 upon pi. So pi with the pi gone, 6, it will be 30 degree. So that's how it goes. Now let's move on to some past paper question to further solidify our concept related to circular measure. In the diagram, OCD is an isosceles triangle. Isosceles triangle means any triangle which is having two equal sides. With OC equals to OD is equals to 10 centimeter. So this part is 10 centimeter whole, and this part also. So it's 10 centimeter. And angle COD is equals to 0.8 radians. The points A and B on OC and OD respectively are joined by an arc of the circle with center O and radius 6 centimeter. Find the area of the shaded region. In part 1 we have to find the area of this shaded region. It's over here. The strategy would be to find the area of this triangle OCD first and then subtract the area of this sector OAB. So shaded area will be equals to the area of triangle OCD minus the area of a sector OAB. That's it. So first we will find area of triangle OCD. We know the formula for finding the area of triangle is half AB sine of C. So half, this whole thing is 10, which is A. This whole thing is B, so it will be 10 only, and then sine point of 8. Now we have to find the area of this sector OAB. The formula for sector we have it will be 1 upon 2 r square, which in case 6 square, because this is 6 over here, considering this, so 6 square theta, which is 0.8. I should write here sector triangle OCD minus area of sector OAB. Alright, this will be 35.8678 and this will be 14.4. So shaded area will be 35.867 minus 14.4, 21.5 centimeters square. Now in the next part we have to find the perimeter of the shaded region. So if we have to find the perimeter of this shaded region, this part is important. We have this side, we have this side, we have to find this side and this side. So first finding the side CD and this, and we have to find this this arc length AB as well. Alright, for finding this side CD first, we have a cosine law. We can apply the cosine law because we have this side, we have this side, and we have the angle in between these two sides. So applying the cosine formula for finding side CD, we will apply the cosine law. So CD square will be equals to square of this side, that is 10 square, square of this side, that is also 10 of square, minus 2 this side and this side, so it will be 10 into 10, and the angle between these two sides is cos of 0.8. I should write here for the general formula for cosine law is a square equals to b square plus c square minus 2bc cos of a. Actually, how do we know if the angle should be a here? Because this is the side which should be to the left side of the equation, so we should substitute the angle of that. For example, if we have a b over here, then I would write angle b here. If we have a c here, then I would write here cos of c. Alright, so CD square will be equals to 60.65 and this CD will be equals to 7.78. Now for finding the arc length of AB, so the arc length of AB will be is equals to r theta, and r is 6 over here, it's 6, and this theta is 0.8, so arc length would be 4.8. So finally the perimeter will be So 4 plus 4 plus this arc length AB, that is 4.8, and this part CD, that is 7.78. So our answer will be 20.6 centimeter. Now move on to the next question. In this question, we have in the diagram AC is an arc of a circle, center O and radius 6 centimeter. The line BC is perpendicular to OC. Alright, this line is perpendicular to OC, and OAB is a straight line. AOC is equals to pi upon 3 radians. That's important. Find the area of the shaded region, giving your answer in terms of pi and root 3. Alright, so in this question, the strategy would be to find the area of this triangle first, and then find the area of this sector OAC, and then subtract it from the triangle, and you will find your required region. So I should write here the shaded area. If you have to find the shaded area, it should be area of triangle OBC minus area of triangle, area of sector OAC. So let's find out area of triangle OBC first. We need to find, but we are not given with this side. So first we'll try to find the side BC, and it's a right angle triangle, so I can apply like half into base into height. So first I have to find this, this side BC, and it's a right angle triangle, so I can apply this formula. 10 pi upon 3 will be equals to BC upon OC. This BC upon OC, opposite upon adjacent. So BC is unknown, and this OC is 6, and 10 pi upon 3 is root of 3. So BC will be equals to 6 root 3. So now I can apply this in here. So 1 upon 2 into this base is OC, and this height, that is BC. We just found this BC over here, so it will be 6 root 3, 18 root 3. Alright, now we will find the area of sector OAC. It will be half r squared theta generally, so half. The radius that we have here is 6, so 6 square, and theta is pi upon 3. Which will be 6 pi only. Alright, so now just substitute these two values in this shaded area formula, and we have shaded area is equals to 18 root 3 minus 6 pi, and it will be 3 root 3 minus pi centimeter square. In this question, the diagram shows a circle. The center O and radius 5 centimeter. The point P lies on the circle. PT is a tangent to the circle and PT equals to 12 centimeter. The line OT cuts the circle at the point Q over here. Find the perimeter of the shaded region. They want us to find this part. So what we need to do for this, we need this QT and this arc length PQ. We just have to find these two things only. And we don't know about this angle as well. They haven't asked us to find this, but we have to look for this angle also. As you could see here, this is a right angle triangle. This triangle OPT is a right angle triangle making a 90-degree over here. So first we will try to look for this angle O. So it will be 10 P of T equals to 12 upon 5. It will be equals to 1.176 radians. Now once we have found this, we will go for this arc length PQ. So the arc length PQ, we know the formula for arc length is S equals to R theta. So R is 5 from here, because this is the radius, that is 5, and the theta that we just found is 1.176. It will be 5.88 centimeter. Now we have to find this QT, but we can't find it directly. So first we will try to find this side OT, and then we'll subtract. First we will find this whole side OT, and then we'll subtract this part, which is actually the radius, and which is 5 centimeter. So what we need to do, we will first find this side OT, and then we will subtract 5 or OQ from OT, and then we would be, the remaining thing will be QT only. So I can write here QT is equals to OT minus OQ. In this we will be able to find this side QT. Alright, so I will apply the Pythagoras theorem first to find this side OT. So OT square will be OP square plus PT square. This OP is 5 square and this PT is 12 square, and this OT is hypotenuse. So OT will be equals to 13 centimeter. Now I will substitute the value of OT in this equation and will find the value of QT out of it. So QT is equals to OT is 13 and this OQ is 5 centimeter. So QT will be 8 centimeter. Now I can find the perimeter, which is the answer for the first part. Perimeter will be equals to this PQ plus this QT plus this PT. So 5.88 plus 8 plus 12 will be equals to 25.9 centimeter. Now in the next part we have to find the area of the shaded region. The strategy were almost the same. What we need to do, we just need to subtract the area of a sector from this triangle. We just need to remove the area of this sector from this triangle, and the rest of the thing will be this shaded part. So first we'll find the area of triangle OPT for part 2. Area of triangle OPT, and it will be 1 upon 2 into 12 into 5, because this 12 is the base and this 5 is the height. So half into 12 into 5 will be 30 centimeters square. Now we have to find the area of the sector OPQ. So area of sector OPQ is 1 upon 2, 5 square, which is the radius, and this angle 1.176, and it will give us 14.7 centimeters square. Now we just need to subtract for the area of shaded region, which is the answer to the second part. So area of shaded region will be 30 minus 14.7, which is 15.3.